Hello and welcome everyone. My name is Vitaly Rudnitsky. I'm a SAP Developer Advocate and I'm the host of Data and Analytics Week of Devtoberfest. We are coming to the end of this week. We had full packed program that we hope you enjoyed as well. We kicked this week off with two great presentations on topic of demystifying data science in the enterprise and as well the modern enterprise data landscape. I had additional session discussing data visualization yesterday. And then on Wednesday, we had two fantastic discussions with authors of different SAP data and analytics books. All these sessions are available for you on our SAP Developers channel for review if you missed them. One more panel that we had yesterday was on the topic of data science in practice, and we had another fantastic discussion with three experts from different SAP organizations who have their hands really dirty in a positive way with data science. And now we are coming to the final Fun Friday activities where we are going to have two sessions discussing coding for kids. We hope that you will enjoy these sessions. And now we are starting with the first one, designing a programming language for all children. And I would like to stop talking and give the microphone, the virtual microphone, to Jens. Jens, the stage is yours.
Thank you, Vitaly. Let me share my screen and see whether it works. Okay. Can you just nod? Can you see my screen?
Yes.
Okay. Folks, I'm here to talk about coding for kids and what we at SAP do to make that happen and to support that. This is not going to be a session where we actually code for kids, but we're going to talk about coding for kids and about how we design the language called Snap and how we make that and maintain that software. It's sort of what we promised a backstage tour of our development lab. So when we say coding for kids and why we're doing it at SAP, we're saying Snap, that's sort of like a gift, SAP's gift to computing education. It's for free, and it's something where we try to share our passion for programming. And so Snap is something that we develop at SAP. It is actually used around the world. It's, for example, a programming language that kids in Palo Alto and Silicon Valley learn in high school. But it's also a really global community of folks that like to program creatively. We've got a little more than 580,000 registered users at our Snap Cloud. There's roughly 280 new signups each day, a little more than 100,000 last year. All these learners have by now produced over 5 million projects, a little less than 3,000 every day. And so it's not the largest creative computing community in the world, but it's pretty great, pretty big, at least kind of from my perspective. And it makes me, as kind of the main developer of the language, actually pretty nervous sometimes. All of this is truly open source. There's nothing proprietary in there. It's all on GitHub. You can look at it. You can fork it. We've got a great community. Snap has been translated into 45 languages, and we've also gotten some award for it last year. So what it is internally, when we talk about the design, it's an interactive visual programming system that runs in the browser. And the reason why it runs in the browser is that we don't want kids to install software. When they use it in school, it's hard to get IT to agree to install something on kids' computers. Intellectually, it looks, and I'll show you in a minute, it looks a lot like Scratch. Maybe you know Scratch, kind of the Lego bricks metaphor of putting together program chunks, kind of like puzzle pieces. But internally, it has the semantics the big ideas of Lisp, of Scheme, and I'm also going to show you in a minute what that is about. We made it together with and for UC Berkeley's introductory computer science course for non-majors, and that course is called The Beauty and Joy of Computing. And really, the beauty and joy of computing, that's our motto, that's our purpose, that's our reason to be. It's not just used at UC Berkeley, it's been rolled out all over the US and in many other countries. US we've got the strongest user base in the US. And you know what? This is the team at SAP, 3 people that really work full-time on these programming environments. This is my colleague Jadka Hügle from Waldorf. This is Bernard Romagosa, who is also an SAP colleague from Barcelona, and myself. And we're doing this together with our friends and colleague researchers at UC Berkeley. There's Brian Harvey, Dan Garcia, and Michael Ball. They're lecturers, professors, researchers at UC Berkeley. And this is a joint project, what we do. And you know what? Let me just show you, give you a brief introduction. If you've seen this before, bear with me. I'm going to show you some new things afterwards. So this is what Snap looks like. It runs in the browser. It's an IDE programming environment, looks a lot like Scratch. Here is something that we call the stage. There's a arrow on there. That's something that we call a sprite. And here are kind of 3 tabs, one with scripts and costumes. If I click on costume, there isn't any costume. There's also kind of a cheesy little paint editor that lets me draw a costume. So I can draw something. I can also, it's really just a very basic editor. But when I've drawn something, it's not just a picture, but it's an object. And I can do things with that object. So on the left side, there's a palette with these puzzle piece blocks that allow me to do things. And one of the design principles of Snap is that it's always live. You can try out anything in the palette. You can always click on something. If I click on move repeatedly, the heart moves to the right. If I click and go to 0, 0, that's the middle coordinate of the stage. It goes right back. I can go to looks. There are other blocks that govern the appearance of the sprite. And one thing is I can change the size. I can click on this and then the heart grows. There's another one that sets it to an absolute size. So I can stick these blocks together by moving them around in the scripting area. There are little suggestions where I can just drop them. There are other categories like the control category. There you find these blocks. Those are events. Now something will happen when I click the green flag over here or when a key is pressed. There are also these C-shaped blocks. These are control structures, forever or repeat. I can drag out a repeat block. I can wrap it around to change size. Now I can put the set size underneath. And this is how we build scripts. Now if I click on this, there's a heartbeat. I can do this, wrap another one out here. Now we're repeating the repetition twice. Now there's 2 heartbeats. I can maybe attach a when I am clicked, not I ends, but I, the sprite, the heart. When the heart is clicked, now the script is going to fire. So now I'm clicking on the heart, the script is fired. And this is how we're building little applications, little games in Snap. A very interactive way, very like you can try out things, nothing breaks. You don't have to think ahead and then see whether something compiles. This is what we call a low floor pedagogy. We want to really invite people to give it a try and to just do things. So low floor, that's one of the design principles. Another design principle is that we want to have no ceiling. By no ceiling, we're saying that we want to express everything that we can express, that we need to express when we study CS in college, at university. We want to be able to express all of that in Snap. And So this is something, I'm just going to go through this very quickly. So we got these different kinds of blocks. The puzzle piece blocks, they do something, like they change the size. We've got these round blocks. They can be used as inputs. For example, the direction of this heart is 90 degrees right now. We've got these little rings, and these little rings are what makes Snap special. The little rings are from the Lord of the Rings, the one ring to rule them all. So just very quickly, my favorite example, if I have the 3 + 4 block, I click on it, I get 7. Now if I put this into a ring, I click on 3 + 4, I don't get 7, I get a ringified version of a block. And if I, so this, the ring prevents the block from being evaluated. And so it sort of packs it up. I can call it again, and I again get 7. So you might already be seeing where this is leading to. Here's one way how we introduce variables. We just leave a blank in there. We say 3 + huh, and we actually say huh. And then we can expand the call block and say, with inputs 5, and you can see maybe what is happening here. So the 5 gets mapped to whichever blank space is inside that expression in the ring. And now we get 8. So what happens here is that we have an expression, and the ring turns it into a function, an anonymous function, and the blank inputs become implicit formal parameters. And this is really a huge idea, that we have anonymous functions, that we have functions that we can make on the fly, because that allows us to make cool things. One thing that Snap is also made for is to build your own blocks. And now I'm just going to build a couple of blocks to show you why it is important. So we've got all these blocks here that you get out of the box. Those are the blocks that we made for you to use. But of course, it's a finite vocabulary. Sometimes you want to make things where you're missing a block. The project you work on doesn't have something. For example, I want to find out whether a letter is a vowel. So here's something I could do. This is a block that makes a list. I can expand these, and now I'm getting a list of a bunch of items. So I can say, okay, the vowels in my alphabet would be A, E, I, O, U. Now I get a list of vowels. And I could, for example, check whether a letter is inside that list, is contained in the list. Now, whether my list contains, for example, the letter E, and again, it's all live, I get true. If I say it contains the letter H, I get false. Now I can turn this predicate, this expression, into a predicate by making a new block. I can say I want to make a reporter block. That's a function. It should be in the list category. And I could say, is letter a vowel? And now I'm getting this block editor. Here is the shape that my block is going to be, and I can define that letter is going to be an input. Now I can already see, if I apply, here's my, oh wait, I wanted to make this a predicate, so I can say this is a predicate. A predicate is a function that returns true or false. So I can change the size, the shape of it. So now you can see the block has turned hexagonal. I can say, is B a vowel? And to define my function, I can just drag this expression in there. You can see on the outside, the letter is just a slot where you can type something in or embed another block into. And on the inside, it's a variable. So it's just a parameter. So I can use this variable here. And now I can do this for any letter. I can say, is B a vowel? That's false. How about O? That is true. Now this is interesting. Now we've made a function and we can apply it to things. Another thing, I've showed you the rings, is that we have powerful ways that we can use higher order functions that sort of get rid of the need to think about loops. So one thing we could do is we could, make a list of letters by splitting something. Like, let's say, welcome to Devtoberfest. This is the split block. If I click on it, I split it by spaces, I get the words. Here's a little drop down that also lets me split by letters. So here's the letters of welcome to Devtoberfest, and I can map my isVowel function over that list. And now I'm getting a list of Boolean values indicating whether each letter is a vowel or not. And with this, I can do some interesting other things. For example, I could say, if the letter is a vowel, then I'm going to do something with that letter. I'm going to say, join that letter, insert a B, and repeat that letter. Otherwise, just leave the letter as it is. This is maybe a very concise way, but I hope you can see the power of this. Let's try this. So now I've replaced every vowel with a letter, a B, and another vowel. Maybe you can already see where this is going to. This is what we call the B language, something that kids like to do. Now all we need to do is join this together. And you can say, welcome to Devtoberfest. In the B language, it says, welcome to Devtoberfest. And it's a very powerful way to express things. And we can, of course, turn this into another function by saying, okay, translate a sentence to a letter language. So it doesn't always have to be just B. So now I'm making a new function. It's already in here. I can say sentence is an input, and I want to make the letter also an input. Now I'm dragging in the expression that I've tried before. I want to make sure that the sentence is this one, and the letter that I want to look for is the B letter. So now I have a function here that I can use to translate anything, like the beauty and joy of computing. Of course, I can turn it to B language. The B, I can't even read that. I can also use another, like I can say, oh, how about this? Now this is interesting. I can also have more than one letter. I could say A, Y, like it's something that looks a little bit like Pig Latin. This is a powerful way where we build curricula, where we let students work with data in ways that are more modern than the traditional imperative approach. This is a very mathy way, very lispy, Schemian way. The beauty of this way is that we can also build things in our language that aren't there. Like one example that we have here is, if you look at the control category, we have these control structures, these loops, and they're a little bit funny because we've inherited them from scratch. There's a forever loop, a repeat until, and for loop, but there is no while loop. Now imagine a programming language that doesn't have a while loop, but with these rings, remember the one ring to rule them all, we can actually build them ourselves. So I'm just going to build a while loop. It's going to be a puzzle piece shaped loop. It's going to say while we're going to test something and we want to make an action. So now I can define how that block is going to look like. We're going to say the action should be such a C-shaped thing. So C-shaped block, now look at that, and I can say, oh, it's going to be a loop, so I can just make a little visual indicator that it's a loop. Now look at this. If I click on this, we get this indication here. There's a letter that says lambda. Now lambda is really a ring. lambda is kind of the Greek letter in mathematics for our concept of the ring here. It's a reified function, lambda, the Greek letter. And you know what? Lambda is the question that you can answer if you want to get the points for participating in the session, because this is our logo, our mascot. This is called Alonzo, for Alonzo Church, who came up with the lambda calculus. And you might notice this, it's gobo from scratch, but the hair are in the shape of this letter, of the symbol of the lambda letter. So you get it, snap is scratch plus lambda calculus. Remember lambda, okay. So, okay, let's actually put this to use. So now we've got this Y block. If I apply it, it changes shape. So we've already got the C-shaped thing. Now we also need a test expression. And the test expression is also going to be an input. But usually when we call a function, we evaluate all the inputs and then we pass them to the function body. Now in a control structure, we need to evaluate the test often at every loop iteration. So we need to make this a ring, remember? And it's going to be a predicate. So I'm defining action to be another ring, and you can see it turns into a ring here. So now I can make a little test case. Let me actually switch back to the turtle costume. I want to make a little test case. I want to make a variable. I'm just going to leave it as A. I'm going to make the pen down. I'm going to say while A is less than 300, move A steps and turn 121 degrees and increment A. Actually, let's increment A first because we're going to start with 0. So now if I click on this, watch what happens here. Nothing happens because we haven't defined while yet. So let's make this new control structure. So first we need to find out whether the test condition is met. So we can use an if to find that out. And test is a lambda, remember lambda? So we need to call it, it's a ring. So we're calling the test. And if it evaluates to true, we want to run the action. We just literally, there's a run block for that. It also takes a ring. So we run the action. So now we've done it one time, but we want to do it while the condition is true. So how are we going to do all the other times? Well, we already know what to do because we're working on it. We take the while block and call it recursively on the test and the action. And I hope when you see this that you notice what we're doing here. So I'm going to apply this. This is a recursive definition of a control structure. Let's actually try this now. So I'm clicking on this and see it's running. Let's see whether it stops. And it stops. So we've made ourselves our own control structure. And this is a feature that not many programming languages have, only the ones that kind of have this way of thinking about with rings or with lambda. And this is the other dimension of our design principle. This is the no ceiling design principle. This is really when we want to say, we want to be able to teach everything that explains even how programming languages work in this kind of playful programming language. There's a third dimension, and that is the one of wide walls. And so let me actually get back to the costume, to the heart costume. Let's maybe make this a little, set the size maybe to 60%. You see, everything is live. One thing that we can also do is play with sensors, play with external data. And one thing that's really fun is, here's a video capture. So if I set the video capture, if I turn the video capture on, there's a picture of me and it's streamed to the stage. and it's a little transparent. We can set the transparency here. By default, it's by 50. If I make it, don't make it transparent at all, it's solid. If I want to hide it, I can set the transparency to 100. Right now, I like you to see me, so this is solid. And now there are things that we can do with that video. And that's actually interesting. So for example, we get this reporter that we can get the video motion on myself. Again, myself, we're in the scripting area of the sprite. Myself is the heart. So if I click on this, there isn't much motion happening. It's 0, 1, even if I'm moving. But if I'm moving my head above the heart, I'm getting higher numbers. So I could say, let's make a generic condition that says when that motion exceeds a certain threshold, like when the video motion on myself is, let's say, greater than 10, we could do something interesting. We could, for example, let the sprite turn into the direction of that video that is detected. Let's try this. So now if I'm moving a hand over here, it's turning in that direction. If I'm moving it back, it's turning in the other direction. And we can also make it move, let's say 20 steps, but be careful that it doesn't run over the edge. And see, this is always live. This is already live. So now I can sort of move this heart around interactively. I can make it so that it doesn't turn. That's kind of nicer. And I've just made myself a little augmented reality that I can use for a game. So this is the third dimension, that we want to have a wide variety of interesting and engaging activities that are fun to explore. And this is the wide walls dimension. Okay, so how does all of this work? How do we make this software? It's a lot of code. It's right now roughly a little more than 130,000 lines of code, basically JavaScript, because everything runs in the browser. And we basically write all of this ourselves. There are no outside dependencies. We don't use any libraries. Everything in the system is kind of made by hand. But I'm not doing this alone. We at SAP aren't doing this alone. There's actually a really great and big variety of contributors, more than 100 over all these years. Even though I'm writing most of the code, many of the very important contributions that are really cool have been provided by others. For example, what I just showed you, the video motion detection, that was contributed by a good friend, Josep, from Barcelona. So many of the cool things have been contributed by the community, and it's a really lively community. People there are tons of forks, tons of people are using it to make other variants, and some variants of Snap are really kind of among my favorite variants. For example, Turtle Stitch is a great thing where you can use kind of Snap to create patterns that you can stitch on your clothes and wear. So yeah, it's mostly JavaScript. It's a huge project. And so how does it work? It's a visual programming language. So we want to see some output, and you've seen we're actually using it to manipulate these figures, these actors, and we do that through, you've seen it through scripts. Scripts are these things that we stack together blocks, and the way this works internally is that when we run these scripts, every script becomes a process, and sort of the processes are working on the actors. So the actors are sort of like puppets that are controlled by these processes. Processes can run in parallel, but they're powered by a single thread managers. They run on top of a single thread, which is actually great. So we have a very controlled multi-threading system. We can have one thread always moving the sprite and another thread always turning the sprite, and it will form a perfect circle, something that wouldn't happen if we kind of had real threads, not green ones. But now, controlling sprites with scripts isn't just the only thing we want to do. We also want to have this interactive experience where we also have an editor that we can use to arrange these blocks. We also want to work with other resources like sounds and images. And we want to have more actors. We want to have a lot of sprites, and we want to interact with things like video or the microphone. And this is why we put more components into Snap, into the software that is really an integrated development environment, something that doesn't just run a program, but also lets you interactively edit it. And all of this runs on top of the browser. And technically what we're using is an animation frame that we get from the browser. So now, in order to get this to run, to actually get this to work, we need to connect Snap with the browser. And for this, we're using our own Morphic framework. Now, Morphic framework is something some of you might know. It's a way to make a user interface kernel that was originally developed by John Maloney and Randy Smith at Sun Systems. It was later ported to Squeak, who was also part of Self. This is something that changed my life. I love that way of thinking, of making a system that is sort of hosted in itself, that is its own operating system. And Morphic really just plugs into the animation frame and does, at every frame, it does three things. It processes user input, it steps through all the other morphs, all the visual components in a world, and then it updates the display. When it processes user input, basically what we do is there are two ways in which the user can interact, through mouse or touch device and through keyboard entry. When we're stepping through morphs, this is when the system comes alive. This is, for example, when we control things like a menu, like there's a representation for the mouse pointer, but not just the pointer, but actually if you drag something, if you drag a block, if you drag a figure, kind of the mouse has the notion of becoming a hand. And there are other system components in that morphic world, as we say. And at the end of every frame, we also update the display. We re-render the damaged regions of the display, the ones that have been changed in that frame, and then we redisplay the whole world. All of this is happening in chunks of 15 milliseconds. That's the animation frame of 67 frames per second. This is what we're doing here. Now, really, what Snap is just morphic system. Snap is really just that. And now that we have this, we can actually also interact with other components in the morphic system. We can interact directly with things like we can let the user just drag these sprites along. We can let the user assemble scripts, and all of this we get out of this very lively integrated morphic system. If you're a web developer and you look at this thing, you notice that usually you don't have this morphic system. Usually what you use is the DOM, the document object model. If you're a web developer, when we developed Snap, we decided against using the DOM, but basically build our own operating system that does all of that for us so we can more tightly integrate it. And so this is basically our stack, if you will. On top of the web, we run our Morphic kernel, we run the Snap IDE, and inside the Snap IDE, we run the evaluator. And if you look at this, I made these gears not just so that they look nice, but it's actually sort of the truth, because all of this runs on top of a single thread, on top of a single process in lockstep. Each turn, 50 milliseconds, does all of that. And so this is all done by us. We kind of make all this code ourselves, which makes it very much maintainable for us because we don't rely on any outside dependencies. Bear in mind that this is only 1/3 of the actual project. That's the third that I'm responsible for. There are two more sides to Snap. One is the community side, where users can maintain their own projects, can access them, can share them. And then there's yet another side that is the backend side, the cloud side, where we store and retrieve and administer the rights of these projects. So this is the Morphic architecture. And actually, let me show you how that looks. You can actually still see it in Snap. So here I'm again in Snap. You remember that I just showed it to you before. Told you that this is really just a Morphic application on top of this framework. There's actually a little trick. If you click on the Snap logo, you get kind of some options, like a menu that let you kind of download the source, find out who contributed, and read the manual. If you keep the Shift key pressed while you click on the logo, you actually get one more option, that is switch to dev mode, enable Morphic. Now, if you do this, the IDE shrinks and you can move it away, and now you can see it's actually something inside another window, and that other window really is the Morphic world. And in Morphic, we can sort of explore this. If you right-click on it, you get a world morph menu, and you can, for example, get some sample morphs. So, for example, you can get a box. Now I get a box. Everything that you see in Morphic is a morph. You can right-click on it to resize it. You can right-click on it to inspect it. Now, if you're a small talker or a self-programmer, you can see this is the border, you can see the bounds, and all of this is live. As I'm dragging this thing along, you can see how the position is changed. If I'm resizing it, you can see how the extent changes of this shape. I can interactively change the color, for example. And I can assemble things. I can combine things. Like I can make another. Let's make it. Here's a dial. I can make the box touch the dial. Then I can set the target of the dial to the box, and I can set, for example, I can say the corner size should now be controlled by this dial, and now I can control the corner size with this dial. I can make something else. Let's make a slider and attach it and set the target to the box morph's border width, for example. Now I can control the border width with the slider and the corner with the dial. Let's actually make this a little bigger. Another thing I could do is I could get something like a color palette. And I can, let's also make this a little bigger. Color palette. And let's attach that, set the target to that, also to the box morph's color, for example. So now I can control the color with this. And all of this is live. All of this is very inspectable. All of this is changeable. I can also see all the methods. I can change them in here. I can edit them live. And this is the Morphic system. And you can see that Snap really is just the Snap IDE, the Snap system, is really just one of these morphs inside this operating system. Now, we use this way of building a system inside a system as a powerful way that lets us really debug Snap as we develop it. We can look into these things, we can also, for example, inspect this sprite now and kind of see what's going on in the sprite. We can see all kinds of like the custom blocks we've made. We can see all the attributes and all the properties, and even change them. For example, when we say here, this is now draggable, and this is true. If I'm going to set this to false and save this now, now it's no longer draggable. I can change this right here and debug it inside Morphic. So this is another really important design principle, that when we build software for kids, we just don't want to throw together things that we get elsewhere and just pick it the way how software is often developed in modern times. Like we just take what somebody else has written and glue it together. We really want to build a system from the ground up, and so that it meets our design criteria: the low floor, the no ceiling, and the wide walls. And really the reason why we're doing it all ourselves is that we can support this kind of interactive, playful liveliness, as we say. And this is why we're doing a Morphic framework. So what's all of this got to do with SAP? Actually, a lot. So this is a picture of an event, a Snap conference we had at SAP a couple of years ago. And Snap really is a way where we can, from SAP, can really share our passion, our joy of computing. This is something, especially, in a country like Germany, this is traditionally about building cars, about tooling, about building machines. It's something where we can express that, software is something that can be really something that makes you enthusiastic. And it's something that if we are able to share that idea that it's something that is also beautiful, something that is great, that will help SAP, and that will also help others that want to learn it. We're also trying to really be ambassadors for SAP's big ideas. And SAP, right from the beginning, the first version was called R1 for real time. So this is precisely what we're trying to share with Snap, the idea that if we do things in real time, not something that we have to plan ahead and then run in the batch process at some other time. If we do things in real time, interactively, that makes for a much more powerful user experience. And as a very practical thing is, we're reaching non-traditional audiences with Snap. It's not just kids. It's really also adults, it's youth, it's students, it's non-traditional audiences with regards to underrepresented minorities that we're helping, that are having fun with Snap because it's not such an intimidating language as maybe others. We're really using it to share the big ideas. It's always easy to, share little things like, oh, here's a variable, here's a loop. But we're really burning with ambition for big ideas. We want to make things like AI. And we've made, in collaboration with other people, really a nice course about artificial intelligence. We're working on a module that we're running out to schools about machine learning. We want to do data science and things like media computation in Snap. So this is the kind of curricular side that we're doing. And it really is about kind of what people say, design fluency and 21st century skills, about being able to not just consume computers and software, but to become active participants, to become truly literate in authoring your own apps, which can be games, which can be interactive stories, which can be things where you just compute something. And in a big company like SAP, not everyone is a developer. In fact, there are huge areas at SAP where people never code something. So there are lawyers, there are HR people, there are accountants, giving them something that they can do with their kids is actually something that, makes them identify with the company, because this is something we do. They can actually share it with their kids. And this is always nice when we do this with colleagues and with kids. And last of all, this is something where we're at SAP are right now venturing into. Traditionally, we're more an enterprise software company. Now with things like Snap, we're really kind of venturing out into realms where we aren't so much before. Like, we're actually working with people who aren't getting paid to use the software. We're working with folks who need to use it in school or who just want to use it. And this is a really great adventure for us to do. So I hope you've maybe gotten a little idea of our design principles and about also how we make Snap. If you're interested, if you like the software side of it, you'll find it. Remember, click on the logo. You'll find it. You can download the source. If you click there, you come to our GitHub repository. You can see everything here. You can download it. You can check it out. You can participate. And I hope you got an inspiration to maybe even check out functional programming. Remember, here's the Alonso. She has, remember, the haircut is a lambda. Lambda can change your life. Thank you very much.
Thank you, Jens. Fantastic. I truly enjoyed this, and actually just reading comments as well in the chat. People are saying, just give me a second. I wish I had such a teaching approach at school when we were kids. Very cool. Love the way this framework is structured. And just one more thing, that was brilliant. Wow, you have moved the hard hours as well. Thank you for creating Snap, Jens. So we got really enthusiastic comments. There were two questions. I believe one of them was already answered about the minimum age to recommended for Snap to start. So Bernard answered that we recommend starting at around 8 years old. Is that, let's say, the correct answer?
I think Bernard is, of course, right. It depends what you would like to do. So we made Snap for teenage level, for high school and college level. So this is our target group, but we made it like Scratch. And when we made Scratch a couple of years ago, we made it for 12 years and up, but it turns out to be great for 8-year-olds. So yes, if you have an 8-year-old and you like to expose them to programming, by all means, use Snap. That said, don't be overly ambitious. We've been observing time and again that teenage actually has benefits also for parents to bear with me. Actually, something magical happens between 10 and 13, and that is that kids become sort of natural abstractionists. They really get to appreciate generalization. For the things that I've shown you, like manipulating data, maybe using kind of functions and recursion like that, this is something I'd say, that's fine once they're teenagers.
Sure. Actually, my comment in the chat was that I hope that, like, just by watching this, we can wake up this inner kid inside of even us.
Of course.
So love that. For those of you watching live, if you have any more questions, please just put them in the chat. And then the second question is quite technical and challenging, I would say. So Andrew Diaz is asking, is there a possibility that Morph architecture will replace DOM in the future?
I'm the wrong person to ask that. Ask the World Wide Web Consortium. The reason why I use the Morphic architecture is that at the time when I started this, this was in 2010, I was building on our previous code that was built on the then code base of Scratch that I was contributing to. And Scratch was made with Squeak Smalltalk. And so the user interface system of Squeak Smalltalk was Morphic, of course. So for me, the natural way was not to use the DOM, but to actually implement a Morphic, so I could do all these things, like I can click on blocks and get the speech bubble. I can do things in a much more live and interactive way to implement Morphic. That said, Morphic is very similar to the DOM. It is also a hierarchy of shapes. So the ideas are really kind of similar. For us, for me, one of the reasons that to use the own system is really to have full control, call me a control freak, over the whole stack. And that is something, so if they change the way how buttons look, if they change the way how scroll bars look, that doesn't affect Snap. Our documentation is still current. We can, and also the behavior, we can define that as we want. And one important thing is that we can experiment with different ways of making user interfaces that aren't your standard widgets that the DOM gives you. And we have quite a few of those.
Thank you for the answers. There are no more questions that I would see right now in the chat, but basically you mentioned about how many contributions you've gotten so far, and you showed that it is available on the GitHub. So that kind of like the question that I planned, now you answered this already. I really hope that more people, more developers who are watching this or will watch this session will decide to contribute to Snap. I'm just checking if there is another question. Okay, so this is another comment. Thanks, Jens, and all the others behind the curtain of that. So, because there are no more questions in the chat, do you mind to just mention, without maybe unveiling all the details, what do you plan for the second session today?
Yes, the second session is going to be more of a hands-on programming session, where we'll probably not go so much into the highfalutin details of functional programming, but we'd like to do more some concrete introductory examples that explore the pen category, and maybe some other categories where we want to kind of, in the larger sense, want to explore some artsy things, some generative art in Snap. So this is going to be something kind of more concrete ideas, things that you can do with your kids.
Cool. Okay, there are no more questions in the chat, so I would like to thank everyone joining live, and I would like to invite you to this second session that is going to happen 5 hours from now on the same SAP Developers channel. Jens, thanks a lot. Like I mentioned in the chat, my son attended 2 of these Snap workshops in the past. He really liked it. Now I got a chance to look behind the curtain, and it was truly inspirational and very interesting for me as well. So looking forward to the second session with Yadga and you later today, and to get even more inspiration. Thank you so much.
Thank you, Vitaly, for having me. This has been fun. Thanks for organizing all of this. I think it's a great initiative. I love it.
Our pleasure. So till later, everyone. Have a good day.